So here we have question 5. Typically grade 10, 11 and 12 have a similar question 5. Now without wasting time, let's look at 5.1. In the diagram below, T has points X and 15. There T has points X and 15. Let's start off by then indicating on the graph itself. So this is T here, which has 0.5, has points where X is X and then Y is 15. Is a point on the Cartesian plane such that OT, so OT apparently is 17. Let's just put it down, 17. So that's OT, right? 17 units. P, which has points -2 and A, lies on OT. There we have it. And K is a point on the, so here's this point K. K is a point on the positive axis, and TOK is equals to theta. So there you have that. So TOK is equals to theta. So TOK is equals to theta. Now determine with the aid of the diagram the following. Let's go. 5.1.1, the value of X. So for the value of X, there it is. It's very easy because I can see Pythagoras. So I'll go 1 R squared is equals to X squared plus Y squared. So we know the points for R, like they said, OT, which is the hypotenuse, is 17. So I'll just put in the R there, 17. And X, we do not know. We can have it as X squared plus Y is 15. So we know the Y, 15. Now before we go further, do you notice where the X is? It's on the second quadrant. It means that the X will be negative. So this should be R squared. Sorry about not putting on the details in. And this one should be squared as well. So what is 17 times 17? According to the calculator, 17 times 17 is something like 289. So what is 15 times 15? Because we are looking for X, we are just going to transpose this 15 squared to the side where we need it. So basically 15 times 15 is equals to 225. So minus 225. Now as I do this, I leave the X squared on that side, which is X squared. Remember, we are just looking for X. So 289 minus 225 is equals to 64. We still have our X squared. Now, what do? We need to find X, right? So X in this case, we can find by squaring both sides. So square your both sides properly. So here, when you square both sides, the square root of 64 is 8. The square root of X squared is X. And like I was pointing out, that it's in the second quadrant and the X is negative there. So this X should be negative. So -8 is our answer for that 2 marks. So we will carry on and write 5.1.2, where now they want us to answer what is determine 10. So tan theta, which is the same as your Y over X, right? Now for this Y over X, we already know the X, we know the Y. So we will have our Y, which is 15 over -8. And then that's our 1 mark. So for number 3, let's look at what they need. Cos 180 minus theta. So we'll write that down, cos 180 minus theta. And for this, we can then also use a method that I know very well, which is then a trig identity or the reduction formula. So if we reduce this, cos 180 minus theta. So where is cos 180 minus theta? Is it in the first or second quadrant? Because this is your 90 stuff. So this minus, it means that it's in the second quadrant, and cos is negative in the second quadrant. Therefore, we'll have our negative cos, which then makes it negative your x over r. Right? So what is your x? Your x is, let's start negative. Let me just put my equals to the negative, and then I'll have my negative 8, which is x, over r, which is 17. And clearly my answer will be 8 over 17. So that's my answer for this one. We move right along. We are trying to finish this section of the question paper in record time. So let's see, we have our sine squared for number 4. We'll have the sine squared theta. Again, it's very easy because we know that sine is your y over r, right? Y over r. So let's carry right along. We will have to replace it properly now. So if we have our y over r, which is 15 over 17, and this should be inside brackets squared, so this squared can be transferred to both numbers. So here we'll have our 225, we already calculated this, over 289, and that is our answer. So our answer is 225 over 289. Now we carry on to number 5. For our number 5, find the value of a. So you see where the a is. So what happens is, because we have 2 points here, we have our x and y, and we've already found x and y. The x we have already picked up on the others. So we'll use 10 to solve this. So 10 is equals to your y over x, which is the same as, remember, we already know the y for the other point, which is 15. And we know the x, which is negative 8. And for the other y over x, we have this. So it's given. Y is a, and x is negative 2. So once you have this, remember you are looking for a. So you can just simply use the 2 to multiply. It's a cross multiply type of thing, but just take this 2 to the other side. So it will be 2 times what? 15. So what is 2 times 15 here? So 2 times 15 is 30, negative 30 to be more specific, over negative 8. And therefore our answer is 15 over 4. Remember the 2 negatives. When you divide a negative by a negative, becomes positive. So that's your answer. We have solved 5.1 to 5.5. Now we carry right along. We're solving. It says we must simplify without using a calculator. We have sine 120 times cos 210 times 10, 2, 3, 15. Okay, so from what I see is these are your special angles type of questions. So for sine 120, what I'll do is I'll check what is sine in the second quadrant. It's a positive, right? Since it's positive, what I'll do to answer this, I'll just quickly go, okay, 180 minus 180 minus 120, I have 60. So I'll have my sine 60. Remember, in the second quadrant, sine is positive, so sine 60 will remain positive here, and then we'll carry right along and do the cos 210. The cos 210, it's in the third quadrant. Now we want a special angle, so for a special angle here, this cos, if we are gonna move it backwards, we are gonna say 210 minus 30, so that we have a special angle. And we know that cos is negative in the second quadrant, so, or in the third quadrant for that matter. So negative cos 30, that's what we have next. And then we move on to the 10 now. So 10, 3, 15. Now this is in what? In your, let's say it's in your fourth quadrant. Now, again, we are looking for special angles. So for this one, we can have our negative again. Let me put this inside brackets so that I can be able to insert this one nicely. Again, it's negative 10, 45. 10, 45. 10, 45. It's another special angle, right? And for the cos, we'll write it as is cos 27. It's already reduced to that first quadrant cos, so we reducing everything to the first quadrant. So everything here is reduced to the first quadrant. So after having done this, in fact, this cos 27, we could have used the reduction formula where we could have said, okay, cos 27 becomes your sine 63, right? Because we have a sine 63 down here. So let me just go cos 540 becomes, let me start off with this cos 540 because I'm gonna change this. So cos 540 becomes, what is 360 minus 540? That's one, let me go 180. So cos 180, because cos is positive in the fourth quadrant, I'll just write cos 180, and I will then have my sine 63, which remains unchanged because I can use a special angle to cancel these out, the reduction formula. So sine 63. So once you are at this point, you can then punch this into your calculator. Sine 60 is the same as square root of 3 over 2, and your negative cos 30 is the same as, again, square root of 3 over 2, and then you have your 1045, which is 1, and lastly your cos 27. Like I said, these two cancel each other, because if you are gonna use the reduction formula, you'll find that sine 90 minus theta is equal to cos theta. So if we were to use the reduction formula, this would reduce to the following. So now we have cos 180, which is also it needs to be punched in. Let me just look at what cos 180 is. So cos 180 degrees is equals to, okay, oh my goodness me. Okay, let me just leave it at that. You can punch it into your calculator and it will give you a value, and then you can then simply simplify the rest. Now let's look at the next question. Prove the identity 1 over cos. Try to collect maximum marks where you can, because you are bound to make mistakes. This is maths, but hopefully they don't over penalize people so that people can still get 100% regardless of any mistakes. So sine theta. So this is the left hand side, right? So this is the left hand side. So we are proving that this side is equals to that side. So how do we do that? So firstly, because there's a negative sign, or we basically have two terms, we have to look at the LCD. Let's come up with that LCD. What is our LCD for this? Because of the plus or minus sign, we have to use the LCD. So it's cos theta open bracket 1 plus sine theta. There we go. So let's look at it. What happens? Cos divided by that cancel that. So you have your firstly 1 plus sine theta. For the other one, now the cos, so it's cos times cos, which is negative. It's going to give us negative cos squared theta. All this will be over this. We don't drop the LCD in this case. You keep the LCD, which is cos theta, cos theta bracket 1 plus sine theta. There you go. So once you're at this point, you are very close to your ending. What you can do in this case is you basically need to ensure that you change this to a reduction. You can use the reduction formula for this one. So how do you use that reduction formula? Okay, let me leave that and then just go